In school, we hear a lot about atoms, but how did we come to the atomic structure that we all know and learn today? It didn't all start out like this. In ancient Greece, people believed that the world was made of 4 elements: earth, fire, wind, and water. The 4 elements would bond with love and break apart by spite. The ancient Greek philosopher Democritus disagreed and believed that the entire world was made of tiny, invisible particles that served as fundamental units of matter. He believed them to be indestructible, physically uncuttable, and constantly in motion. Let's fast forward to the 1800s with Dalton's atomic theory. Through scientific experimentation, Dalton concluded that all the atoms of the same element are identical, and that atoms are the smallest form of an element. In fact, they are so small that there are more atoms in a glass of water than there are glasses of water in all the oceans. However, if an atom is split, it is no longer considered to be that element. Atoms can combine physically, but they can also chemically bond through a reaction. A chemical reaction is basically the separating, joining, and rearranging of atoms. But one element can never become another. So we know what an atom is, but what's in it? English physicist J.J. Thomson performed an experiment in 1904 involving a tube with gas pumped into it. There were 2 plates with high voltage running through them. One plate was negatively charged, while the other was positively charged. A cathode ray formed between them, and it was directed at a plate with negative charge. It repelled while it attracted plates with positive charge. By the laws of electricity, like forces repel while opposites attract. Because any gas pumped into the tube gave this result, all elements contain electrons, or negatively charged subatomic particles. But if all matter has a negative charge, shouldn't that mean that everything we touch electrocutes us? Well, not exactly. All atoms have protons with positive charge that neutralize matter. At this point, the atomic structure shows what's inside an atom, but how is it arranged? Rutherford conducted an experiment by shooting alpha particles at a thin sheet of gold, expecting it to go straight through. A few did, but some reflected off at wide angles and even bounced back directly. He later concluded that this is because of the nucleus, the extremely dense center of an atom that has a positive charge made of neutrons and protons. This means that the alpha particles bounced off the nucleus, while others went straight through what Rutherford concluded to be empty space. Niels Bohr thought that Rutherford's model was incomplete because the electrons would crash into the nucleus and be unstable. He proposed that the electrons orbit the nucleus with a set amount of energy. If an electron were to jump to another shell, it would cause radioactive energy. If the electrons are on shells closer to the nucleus, they will have lower energy and be more stable. Robert Millikan conducted a famous experiment to find the actual mass and charge of an electron. Between 2 electrodes, droplets were sprayed, and the ones that caught electrons were studied, finding that the mass of an electron was indeed very small, but still measurable. In 1932, physicist James Chadwick discovered the neutron, a neutral subatomic particle. He studied under Rutherford, so he followed a similar method of throwing alpha particles at a beryllium atom. Radiation formed, and so he concluded the existence of the neutron. So many people have contributed to what we know in science today, but there's so much more. Who knows what else science has in store?